Hello everyone and welcome. Today we are going to explore two of the most frequently asked concepts in data science interviews. R squared and adjusted R squared. These are fundamental metrics used in regression analysis to evaluate how well a model fits the data. If you've ever built a regression model and wondered how good is this model really, these two metrics are exactly what help you answer that question. Let's break them down clearly and in detail. Understanding R square and adjusted R square. Let's start with R square, often written as R square. In simple terms, R square is a statistical metric that tells us how much of the variation in the target variable, the thing we are trying to predict, is actually explained by the features or input variables in our model. Its value always lies between 0 and 1. An R square of 0 means our model explains none of the variance in the data. It's essentially just guessing. An R square of 1 means the model perfectly explains all the variance, which in real world scenarios is extremely rare and often a sign of overfitting. Generally speaking, a higher R square value indicates a better fitting model. However, R square comes with a significant limitation that every data scientist must be aware of. R square always increases or at best stays the same. When you add more variables to the model, even if those variables are completely irrelevant, this is a problem because it can mislead you into thinking your model is improving. When in reality you are just adding noise, this is where adjusted R square becomes critically important. Adjusted R square is a smarter, more reliable version of R square. It takes the number of features in the model into account and applies a penalty for adding variables that don't actually contribute meaningfully to the model's predictive power. Unlike regular R square, adjusted R square will only increase if the newly added variable genuinely improves the model beyond what would be expected by chance. If you add a useless variable, the adjusted R square will actually decrease, giving you a clear signal that the variable is not helping. The key takeaway here is this: use R square to set a general sense of how well your model fits the data. But always rely on adjusted R square when you are working with multiple regression models and comparing models with different number of features. It gives you a more honest and reliable picture of model performance. Segmentation versus clustering. Excellent. Now let's move on to our second interview question. What are segmentation and clustering? These two terms are often confused with each other because both involve dividing data into groups. However, they are fundamentally different in their approach and application. Understanding this distinction clearly can really set you apart in a data science interview. Let's start with segmentation. Segmentation is the process of dividing your data into groups based on predefined rules or criteria that you, the analyst or business, define in advance. It is a rule-based approach where human judgment and domain knowledge drive the grouping. For example, a marketing team might segment their customers based on age groups, income brackets, or geographic location. These categories are decided beforehand and applied directly to the data. Segmentation is straightforward, easy to explain to business stakeholders, and works very well when you already have a clear understanding of how the data should be divided. Now, clustering is quite different. Clustering is an unsupervised machine learning technique where the algorithm itself discovers the natural groupings or patterns within the data. Without any predefined labels or rules, you don't tell the algorithm what groups to like for. Instead, it analyzes the data and identifies clusters of similar data points on its own. Based purely on mathematical similarity, a classic example is k-means clustering. where you specify the number of clusters k and the algorithm automatically assigns each data point to the nearest cluster center. Clustering is particularly powerful when you don't have prior knowledge about the structure of your data and want to let the data reveal its own hidden patterns. To summarize the key difference, segmentation is rule based, you define the groups. Clustering is algorithm based. The model finds the groups. Both techniques are valuable and serve different purposes depending on whether you have domain knowledge to guide the grouping or whether you want the data to speak for itself. Thank you.